Hi everybody, my name is Aida Cuni Sanchez and I work for the Department of Environment and Geography at the University of York, and I study tropical forests. And today I'll be talking about the sinking feeling, how tropical forests are losing their power to help humanity. But before I start, let us just take a breath. So when we breathe, humans, we breathe in oxygen and we release carbon dioxide. As you may know, carbon dioxide is one of the greenhouse gases. And it's not just produced by humans and animals, it's also produced by our transport, by our cars, by our industries, and also by deforestation when we are burning forests. And there's a lot of carbon dioxide in the atmosphere, and it's one of the greenhouse gases contributing to climate change. But I want to talk today about plants because plants are magic. So plants actually do the opposite. They breathe in carbon dioxide and they release oxygen through a process that scientists call the photosynthesis. And you don't need to know the details. The idea is that because they breathe in carbon dioxide and they release oxygen, they're helping us mitigate climate change. And I want to talk about tropical forests because tropical forests are a little bit different. You know, in the tropics, the winter is not too cold, like here in UK. You know, in UK, the trees shed the leaves in winter, so they stop growing. So in the tropics, because it's not too cold in winter and not too hot in summer, the trees can grow the year around and they can continue to do the photosynthesis during the whole year. So actually they keep growing, they can get very big, and they can remove a lot of CO2 or carbon dioxide from the atmosphere. And just to give you a figure, tropical forests remove 46 billion tons of carbon dioxide from the atmosphere during the 90s. And in the following decade, they removed 25 billion tons. This seems a lot of tons, right? But let me give you a sense of what this means. So this difference between 46 and 25 billion tons, it's about a decade of fossil fuel emissions from the UK, Germany, France, and Canada combined. So you can see the tropical forests are really helping us mitigate climate change because they're removing a lot of carbon dioxide from the atmosphere. So they're removing part of this greenhouse gas that we are producing. But the question is, will they continue to help us forever? Will the tropical forests help us mitigate climate change by removing a lot of carbon dioxide from the atmosphere for a long time? And I'm going to talk about how the scientists study this and why this is important in a second. But let me just explain something first. So as we are producing more carbon dioxide and there's more in the atmosphere, trees can grow a little bit faster. It's a bit like a chicken. If you have a chicken and you give him more food, it can grow a little bit faster, right? But there's a limit. There's a point that you cannot give him more food and he cannot grow any faster, right? There's a limit. And the problem as well with the tropical forest is not just that there's a limit of how fast they can grow because of more CO2 in the atmosphere, carbon dioxide. It's also that at some point, tropical forests start to be affected by the increased temperatures and also by the changing rainfall patterns caused by climate change. So how do we study these tropical forests? So we actually measure the diameter, we measure how fast they are growing. And it seems pretty straightforward, right? We have a tape and we measure the big trees in the tropical forest. So what we did is that we measured 300,000 trees in the three tropical forest regions, the Amazon in South America, the Congo Basin in Africa, and in Southeast Asia. And I didn't do this on my own, as you can imagine. We were 181 scientists from 36 different countries in the UK, in Europe, in North America, but also in the tropical countries themselves. And just to give you a feeling of how this works. So we measured these 300,000 trees over time during about 30 different, during 3 decades, more or less. And we have 1 million diameter measurements from 17 tropical countries. And it takes 5 days for a team of 5 people to measure 1 football pitch of tropical forest, 1 hectare. This is more or less the places that we are monitoring. And in this 1 football pitch, we have between 400 and 600 trees. And the greatest challenge is not just measuring the trees, is actually getting to the place where these plots that we are monitoring, because sometimes it takes a week to get there. And just to give you a feeling of how this works, so we are a team of people and we pack a lot of food because we work often in protected areas, so we're not allowed to go hunting and there's no crops there, or there's few fruits that we can harvest to feed ourselves. We pack all our gear and our food and we take the road, usually through logging concessions in very muddy roads, as you can see on the right hand picture. Then sometimes we have to use canoes, and sometimes you have to push the canoes in the swamp forest when they get stuck in the sand or the mud. And then after the road or the canoe, we have to walk for a few days, crossing rivers and swamps. And sometimes the rivers are overflowed, as you can see in the bottom right picture, so it's not so easy. Finally, when we get to the place we want to be, we camp. And usually we take a team of quite a lot of people, because we need the porters and we have the scientists, and we also have students that we are training to do this work. And finally, we measure our trees. Sometimes our trees are very big and they have deformities, so we have to use ladder or climb the trees to get to the place where they're straight and they can be easily sampled. And sometimes we encounter different adventures, we can call it like that. So the rainforest has elephants and gorillas, which can be quite dangerous. They can be aggressive and they can attack the scientists. And as you can imagine, it's not very easy to run in the rainforest with your rain boots. It's very thick and you carry your heavy backpack, so it can be quite dangerous when you face these animals. But sometimes you also find the poachers of these animals. So here in the top right photo, you can see an elephant that was hunted for the ivory. And luckily, we didn't find the poachers this time. We only found the remains, and we called the rangers of the park to come and check and report the carcass. So you can see it's not so easy to get there. And once you are there, I just want to give you a feeling of how it works. So we have a team of our technicians and scientists. We go to the place, this one football pitch of forest where there's between 400 and 600 trees that we are monitoring over time. And we measure every single tree using a diameter tape, as you can see here. And then we also record the height of the tree using a laser. And we look at the species, because the wood is different density according to the species. We tag the trees and paint them at the exact same spot where we measured, so they can be remeasured and found again after 5 years or so. And usually we also have a ladder to climb the trees that are, as I said, they have deformities. And there's a lot of trees to be measured, and it's not so easy, as you can imagine. Sometimes, although we have botanists with us, there's trees we don't know, and we have to take leaf samples or flowers or fruits if we find, and we take them back to the camp to be pressed and to bring them and send them to an expert to identify them later. So this is more or less what we do when we are in the plot, measure all the trees inside, and then in the evening we go back to our camp. Here is nice and sunny, but this is a rainforest and it rains nearly every day. Sometimes it can be quite miserable to work in the rainforest and not so easy. Here we have our botanist that is pressing one of the samples of a tree that he doesn't know. He's going to put them in the paper, and then to avoid it rotting, because it's very humid in the rainforest, he's going to put it in this plant press that we call, and hang it over the fire so the smoke dries the leaves. And although they might be a little bit dark in color, they can be at least not rotten, and then will be sent back to Kew Garden or Royal Botanical Garden in Edinburgh to be identified later. And this is our campsite. This is our living room, and our cook is making us dinner. And this is our team enjoying a little bit of rest before another day of hard work. And this is just in the forest, but the work doesn't stop in the forest. It continues after we are back. So we identify the plant samples, and then we make our calculations. So what we define, so what we found is this, and I know it's kind of a crazy table, but let me help you understand this table. So if you look for Africa, there's the bold color indicates how much carbon was removed from the atmosphere for every 1 pitch of rainforest in Africa, 1 football size hectare. So during the 80s, it was 0.3 megagrams of carbon or tons of carbon. During the 90s, it was 0.67, In the year 2000, it was 0.7, but after that, it started to decrease 0.6, 0.63, 59, and 55. And if we look for the Amazon, it was 35, also in the 80s, 53 in the 90s, and then it started to reduce 0.38, 0.24, and so on. And it got to a point in the 2030, we predict, where they will stop removing CO2 and they'll start emitting because of increased mortality. And when we put this in a graph, hopefully it's a little bit easier to understand in a graph. We look at the middle figure, we see that the growth of the trees increased in the 90s, and more or less it reached a limit, because although there's more CO2 in the atmosphere, the rate of growth cannot increase anymore for these tropical trees. And when we look at the bottom figure, this is mortality. We can see that the mortality decreased a little bit in the beginning, but then it started to increase over time, particularly in the Amazon, which is the brown line. It's increasing over time because of increased droughts, increased temperatures, and changing rainfall patterns. And the top figure is the sum of these two bottom ones. So what shows is that over time, the tropical forests will be removing less CO2 from the atmosphere than they are doing now. And the take-home message is that the uptake of carbon by the tropical forest has already peaked. It actually peaked in the 90s, and the sink will end sooner than even the most pessimistic climate-driven vegetation model predicted. So among all the scientists' predictions that they were made, all of them are wrong. Actually, the peak of the sink already passed and is not there in the future, which means the climate change impacts will be more severe than predicted, because the tropical forest will not be helping us for as many decades as we predicted, right? They will not be removing as much CO2 from the atmosphere as we predicted. And then the role of the tropical forest will only stabilize once the CO2 concentrations in the climate stabilizes. And this, as you know, doesn't depend on the trees in the forest. This depends on us as a society, on what we do. So what can we do as a society? So to me, the first point, and I think it's pretty straightforward, is we need to stop deforestation and degradation of tropical forests. So even if they are affected by climate change, there's more of them, so they can help us a little bit more because there's more surface. So stopping deforestation is a must. And step number 2 is reduce the emissions. So although there's greenhouse gases out there, the mortality that we predicted will increase less, because there'll be less CO2 and less climate change impacts. But this is for politicians to do, right? These are the politicians that create new laws, they put carbon taxes, and they actually make the rules of how things go and then implement them. But the question is, what can you do as a person? Or what can I do as a person? And I want to remind you that as a consumer, your choices are very powerful. So just to give you 2 examples. So when you buy chocolate, one of the products, ingredients on many chocolate bars, for example, is palm oil. And palm oil is produced in Southeast Asia, and actually is the main driver of deforestation of tropical forests in Southeast Asia, is palm oil production. So when you buy chocolate bars, check, do they have palm oil? And where is this palm oil from an old source that it was already palm oil, or a new source that contributed to deforestation? When you buy beef, for example, if the beef comes from Brazil, most likely it also contributed to deforestation, because cattle ranching and the production of soya to feed cattle is the main driver of deforestation in the Amazon. So you as a consumer, you also have powerful choices. When you buy products, it may be contributing to deforestation or not. But also, as you know, depending on the way you transport, if you use, for example, a bicycle, or if you share your vehicle, you're also producing different emissions. So you're also contributing differently to climate change. So think about it. As a consumer, your choices are powerful. There's many of us that are consumers, right? So we don't need to wait for the governments to make big decisions. Your own decisions can also help mitigate climate change. And in this case, also tropical forest deforestation and degradation. I assume you're already not buying red timber, for example, from the Congo Basin, contributing to deforestation. So it's not just the timber, there's many other things you can do to help prevent deforestation and to reduce your emissions. So that is it. Hopefully, as you know, this work was not done by myself. It was 131 scientists from different countries, and now it's a product of what we call the African Tropical Rainforest Observatory Network, AFRITRON. And there's many funders that contributed to this work, and many field teams, many local people that help us measure these trees in the very remote areas of the rainforest. And I just wanted to highlight that this work was published in Nature, which is one of the most famous journals for science, because it was quite a breakthrough that we found that the tropical forest will not be helping humanity for as long as we thought. We need to really think the way I think it's more urgent to change the way we behave and we do things than we ever thought. So that is it. Thanks a lot. And hopefully your take-home message is that as a consumer, you also have power in your choices, so make wise choices. Thank you.